Hello guys, if you like my awesome gaming videos, my programming and web development courses, my editing courses and editing videos, and my tech talks and tech guidance, then you can consider subscribing to my channel and click on this bell icon to stay connected with me all the time. So hello guys, welcome to my channel. So in this video I'm going to talk about the nodal analysis, which is really important to find the node voltage. It's really important for engineering student, especially computer science or electrical engineering or any engineering field student. You must have to identify this. You must know this because this is not in the syllabus of A level, O level or HSC or SSC level. Okay, this is a little bit of higher level study. But this is really simple. If you are just a normal student who wants to learn about it, it is really easy for you, because I think you will find it really interesting how we can work with it. And you definitely want to understand the Ohm's law before understanding this kind of thing. Okay, so what it says that in the first step, so in the nodal analysis, what we say call it as node voltage, because we want to find the node voltage in nodal analysis. So this is the most elementary thing you have to know, and we can find it by V divided by R is equals to I from the Ohm's law, as we know. If you watch my previous videos, you will really understand it properly. Okay, so what we have to do first, in the first step, we have to identify the nodes, how many nodes we have. From this formula, branch minus loop plus 1 is equals to node. So many people find it really hard to identify how many nodes are there. So it is really simple. How many branches? So these are the individual element and the components we have in this circuit. 1 element, 2, 3, 4, 5, total 5 element, minus loop. How many loop? 1, 2 and 3 loop here. Okay, 3 loop here. So 5 minus 3, 2, plus 1, which is 3. So total 3 nodes we need to identify. So what are the nodes? So these nodes are the thing that is really important. So this is one node, or you can call it a junction, because this current is flowing from here, it is coming here, is dividing into multiple parts. So this is a junction or node, you can say, where all the components meet each other. So it is suppose node 1, we can call it as a V1, because this is a nodal analysis, and in nodal analysis we called each node as voltage, V1, V2, V3, like this. Okay, and another one is this one is another node. This is also junction. As you can see, they all are took a different direction. Its current is going out from this junction, and some kind suppose in coming into this junction, and they're just going into this. This is another junction definitely. So suppose I call it a B2. So it says that we need to have total, using this formula, we have total 5 elements, minus loop is 3 loop plus 1. So we have 3 nodes here. So we already know this. Okay, so which is another node? So we need to find out the other node. Which one? So this is the reference node, as I said here, reference node, and this is the reference node. Why? Because as you can see, all the elements, there another point is connecting in this node. So all these points are same. Okay, all these points are same. There is nothing in between. All of their another point, like this is a current source, and is one point is there, this resistor's one point is there, this resistor one point is there, this current source point is there. So all is meeting, all of them are meeting in this bottom line. So is voltage, reference voltage, it should be V is equals to 0 volts. Okay, 0 volts. So this is the most important thing to identify. First we need to identify how many nodes we have, including the reference node, and it should be 0 volt. So this is really elementary thing, and make equation for those nodes. Now we need to just find out the equation for V1 and equation for V2, and if we solve those two equations, we can really get the answer properly. And one more thing is really important. If the current enters, suppose the current is entering into this node V1, it should be minus, it should be negative. So if the current is leaving, suppose it's just like this one, this is leaving from this node, so you can consider it plus. So we need to write the equation now. Suppose at node 1, so this is really important, at node 1, what should be our equation? Our equation is, as you can see in this position, we can apply KCL also, it will also work, Kirchhoff's current law. It means the summation of all the current entering and leaving in a junction, and their algebraic sum would be 0. We can use this formula, V divided by R is equals to I here. This is the most important thing. Now if we are considering V1 node, and definitely this is a V1 node, and if you are considering this V1 first, because we are working with this, so V1, okay, minus V2 here. So what is the difference of the node voltage here? And we need to divide it by 6, because we have in between we have 6 ohm resistors. So V divided by R. So total is, this is the current that we are working on, okay, in terms of voltage. And we're gonna find the voltage here, because this nodal analysis is all about the we need to find the voltages, V1, V2, V3, how many node voltage we have. Main purpose of nodal analysis is to work with the nodal voltage. So that's why this is the important. We need to find V1 minus V2 upon 6. This is because the 6 ohm resistor is between them, okay, then positive, and this is actually the I, okay. And then what we have, V1 minus another, this is actually, we can call it as 0 because this is reference voltage, and V1 minus 0 because there is no voltage here, it is 0, and there is 2 ohm resistor, okay. And then we need to work with this position as well, because we have worked with this one is also done, V1 minus V2, V1 minus the reference divided by 2 because 2 ohm resistor there. We need to work with this 3 ampere current source, okay. It is also entering, because it is entering, as you can see, if it enters it should be negative sign, so negative sign, and it should be 3. Totals is equals to 0. It means the total current entering into a junction and the total summation is 0, okay. So this is the thing that we are maintaining, and this is all done because of using this equation, V divided by R is equals to I, okay. Here is also V divided by R I, and this is directly given, 3 ampere is directly given, so I is equals to 3 ampere. Entering is directly given, as it is entering it should be negative sign, it is directly given, we don't need to calculate it. So this is very similar. Now if you just calculate it, it would be similar, 6 and it should be V1 minus V2 plus 3 times V1, because 2 times 3 is 6, 3 times V1 is equals to 3. You can take it up to another positions, and total for V1 minus V2 is equals to 18, okay. So this is the equation, this is the first equation. Now we need to work with node 2. This is our node 2, and now our leader is V2. We need to all work with the V2. So in the node 1, the V1 is the leader, we need to work with it first. V1 minus 0 over 2 and V1 minus V2 over 6. So V1 was the leader, now V2 would be the leader, so that is most important thing. Now I need to work with, suppose V2 minus 0 or V2 minus V1, we can consider it, suppose. So V2 minus V1, it can never be V1 minus V2 because we are working for the node 2, so it should be the leader. All thing we consider from the V2. So V2 minus V1 divided by 6 because there is 6 ohm resistor between this, and suppose V2, and we have 7 ohm resistor from the 0 voltage, so V2 minus 0 over 7, okay. So V divided by R, this is the total current in terms of node voltage. We need to find the V2 here, the two equation we need to find the node voltages. Suppose we want to find the node voltage of V1 and V2, so that's why you need two equations here similar. Now the current source, suppose in this node V2 the current is leaving, so as you can see, if the current is leaving we can add a positive sign to it, and this is 12, so overall is 0, okay. So the total current is entering and leaving from the junction, their arithmetic sum is actually 0. So if we calculate it, it would be a little bit bigger, and 7 times V2 minus 7 times V1, and 6 times 7 42, so 6 V2, and we can consider it minus 12, and it should be 6 and 7, so 13 V2 minus 7 V1 is equals to minus 504, and these are the two equations. So this is equation number 2 and this is equation number 1. So these are the two equations that you must solve to get this answer, and use calculator or substitution method, any other method you can find, you will get the answer. So the final output should be V1 is equal to minus 6 volt and V2 is equals to minus 42 volt. I may be wrong in some calculation, but you can do it by yourself, and this is a very easy thing to do. Normally the most important thing is the node voltage. If you can calculate it based on node 1, we need to calculate V1 minus V2, and between them we have the resistor V1 minus 0, and we have the ohm resistor, and we need to consider the current, because this node, the current is also entering in this node, so we need to work with this. And from the V2 is similar V2, and when we take the V2, it should be the leader V2 minus V1 upon 6, V2 minus 0, because we are working with these two node voltage, and between these two node voltage we have 7. Okay, and their current is leaving, so we need to consider all the thing here, what is going on that particular node. So if you calculate all of those things, apply the nodal analysis on all those node voltages, you can really find the two equations. If we have two node voltages, if we have one more complicated circuit, another node voltage, we get another solution, and you can get the solution by easily by 3 equation solution. You get 3 variable, and you can solve any complicated nodal analysis very easily if you understand the concept. So this is another part, and so this is another example of super node analysis, which is really important and a little bit of complicated compared to the previous one. So that's why I have taken this example, because this is really important for you to understand it. So I think you should understand the super node analysis as well along with the node analysis, because this is really important. So first, what we have to do, we need to follow the steps, which is find the node. So as you can see, we need to find the node. So this is another node. Suppose this is V1. Okay, and as you can see, this current is entering into this node, and one resistor we have all. So this is a junction as well, and we have one voltage source is also connected with it, and the resistor and the current source is also working with it. So you can consider it V2, and there is no resistor along this, so this is also V2. So the total line, so this is the whole is V2. So this is V2 node. Okay, so V1 node. Okay, so we need to work with the reference node as well. This is as you know, this is the reference node, and its voltage is always 0. We need to calculate this also, and this is reference node. Okay, so what you need to work on. So everything is same as before. So what's the difference? As you can see, between those two nodes V1 and V2, previously we had only one resistor, so we could write V1 minus V2 divided by the resistor. But now we can't do this directly, we can't do this, so we can't just connect it. So what we can do, we need to work with V1 and V2 separately. We can work with V1 and V2 separately and combine them. Okay, we can combine them. So as you can see, why it is super node analysis, because V1 and V2 are connected with a 10 volt source. Okay, so between those two node analysis, between those two voltage difference, we have another voltage source. Okay, so that's why we call it super node analysis. So we directly can't work like we do in the previous examples. So let me show you what we can do. We need to combine everything so that we can find these two equations to solve this two node. Okay, so this is super node analysis. So what we have to do? Okay, so this is, and so we can just write V1 minus 20, V1 minus 20, and this 20 is the voltage source, is directly given, so we don't need to write anything. So V1 is the voltage source or the node voltage we don't know yet. So V1 minus 20 volt, and in between we have 5 ohm resistor, so V divided by R. One more thing, we have reference node V1 and then reference node, and between we have 10 volt resistor. So V1 minus 0 for the reference node, and in here we have 10 ohm resistor, and V1 minus 20, because this voltage is directly given, we can write V1 minus 20 over 5, because between them we have 5 ohm resistor, and V1 minus 0, which is the reference voltage, over 10. Okay, so V1 is done. Our V1 work is perfectly done. Now we need to combine V2, and we need to calculate V2 separately. What we can do, we can write like current is entering into the V2, as you can see. So, and V2 minus 0, because we are working with the V2 now, V2 minus 0, and we have 20 ohm resistor along this 2 node voltage. And what we have here, current is entering into this, so it should be minus 4, so total is 0. But yet we need to consider this V1 minus V2, how we can solve this thing. So this is the tricky thing here. One more thing is really important. If you consider V1 minus V2 V1 minus V2, V1 minus V2 is equals to 10. So how we can write V1 minus V2 is equals to 10? Because as you can see, if we consider V1, the current is flowing from this direction because the positive side is this, and the higher potential to lower potential, the current is flowing through this. So if you consider the current is flowing from this side, the plus sign, and it is going to the negative sign. From the positive to negative, the current is flowing. So if you consider that this is the positive one, then the 10 voltage, so V1 minus V2 should be 10. If it is like this one, current is flowing from this side, positive to negative, current is flowing from this side, then it should be V2 minus V1 is equals to 10. But it is going opposite side. The current is going from the left to right, so it should be V1 minus V2 is equals to 10. So this is the equation we need. Okay, if V1 is the positive side of the current, because this is the going from the left to right and V is on the right, okay, then V1 minus V2 is equals to 10. If it is going from this side plus to minus, then this should be V2, and then it should be V2 minus V1 is equals to 10. It would be different for the opposite direction. Okay, if this was like this, positive and negative. Okay, so this is the two equations that we did. So let me just write those two equations. So this is our, suppose, first equation. First equation is V1 minus V2 is equals to 10. And our second equation is we need to calculate this thing. The second equation, we can find V1 minus 20 over 5 plus V1 by 10 plus V2 by 20 is equals to 4. So if we just work with it, 5, 10 and 20, we are just finding the LCM 2 and 4. So this is 2, 1 and 2. So total is 20. So this is the LCM 20. So 4 times 5 is equals to 20. So 4 times V1 minus 4 times 20 is 80 plus 2 times 10 is equals to 20. So 2V1 plus V2 is equals to 4. 4V1 plus 2V1. So 6V1 plus V2. 6V1 plus V2 minus 80 is equals to 4 times 20, which is 80. So if I just take it, 6V1 plus V2 is equals to 80 plus 80, which is 160. So this is the two equation that we must solve. So this is the equation. 6V1 plus V2 is equals to 160. So you can take it as for yourself, because the calculation might be different for you. I can make some slight mistake, you can adjust it, but this is the normal equation, that the two equation that you need. This is the whole equation, combined V1 and V2, because we can't write, like in the beginning we just can't write V1 minus V2 easily. First we need to work with all the thing that is connected to V1, like V1 minus 20 over 5 and V1 and the reference V1 minus 0 over 10, and separately we need to work with V2. And what are the thing is going on? V2 minus 0 over 20, this is another part, and the current source is entering, so it should be negative. So this is the part where we worked with the V2 node voltage, and this is the part where we worked with the V1 node voltage. We combine it and make it a full equation, and the equation result is 6V1 plus V2 is 160. And another equation is like this one. This is the most important equation, and the rule is, if it is going from the positive to negative and the V1 is on the positive side and between in the negative corner, we should write V1, because this would be the leader, then V1 minus V2 is equal to 10. So these are the two equations we must follow to find the super node analysis, because in between them we have a node here. Okay, because in between those two nodes we have another voltage source. That's why we called it super node. So this is the most important thing that you understand, and I think you will understand everything in the node analysis here, including the normal node analysis where we separate everything V1 V2 and solve those equations, and also super node analysis where we have the voltage source across those two node voltages, So which is the thing that we call is supernode. So we understand every single thing like node supernode analysis in general very easily and properly with the two equation solutions very easily. So I think you will understand everything, including everything you need to understand of the node analysis, and you can easily use it in different complicated circuit as well. In the next part I'm going to talk about the mesh analysis. Till then, take care, bye bye. I'll see you in the next video. Okay.